Hello friends, so here we will going to see some important questions of the physics which are related with the wave optics chapter. We know that important question usually going to get asked in the board exam of the 12th class physics. Okay, so I will going to explain you some two important questions. Those questions were previously asked in the board exam also. So I have picked up those questions in such a way that most of the students going to find out a difficulty to solve those questions because they are related with the interference and the Young's double slit experiment. So I will going to tell you the step-by-step solution of those particular questions. I have already solved those questions and I have given you the detailed solution, and I will going to explain those solutions step by step, so it will be easier for you. These are the questions which anyone can't miss, because there are more chances of having such questions in the board exam, and usually every year questions based on the interference pattern usually going to get asked. Okay, so we'll start here and we will see the solution of those questions. Just watch this video till last, so you will going to get the idea how we have taken each and every steps in the solution, and it will be easier for you to understand the solution, so that you will going to solve that question in the board exam also. I am not saying that that exactly question will be there or not, but obviously they are the question which are asked in the board exam, and similar questions maybe, and obviously there will be the similar questions. Okay, there are the 80% chances of those questions and all, and I know, being a teacher, I know that many students going to face those problems, or lots of the doubts regarding the questions of the double slit experiment, because there are the lots of the formulas and there is a lot of a technicality. So we're going to see here. So you can see on the screen there is one question that is given from the board exam of 2023. It is related with Young's double slit experiment. Okay, fine. So what is given here, we can see in a Young's double slit experiment, yes, S2 minus SS1 equal to lambda by 4. So this, yes, S2 and SS1. So path difference of this particular first case is given, that is lambda by 4, where S1 and S2 are two slits as shown in the figure. Find the path difference S2p and S1p. Now we have to find out this path difference in between the S2p and S1p in the second case for constructive and destructive interference at the point P. So what we have to find out here, we have to find out the path difference between the S2p and S1p at point P for both cases, constructive and destructive interference. So obviously after reading this question you will going to get confused, but don't worry, don't get afraid with such questions and all. Just think logically, because whenever we going to see the concept of the wave optics, or YDSE, that is Young's double slit experiment, or interference pattern, so usually we learn first the formula of the path difference only. Yes or no? Yes. And we know the path difference is generally given by the yn also, or it is also sometimes given as the delta x. Okay, now I will go for the solution. So from the solution you will going to get the idea, and you will say later on that yes, this was a very easier one. Fine. Now I have drawn here the diagram. So I have taken, this is the given one. I have solved this question on the paper, so I hope that you can see this answer very clearly, because I have written it very neatly and cleanly, so that you will going to understand the solution. Now what is this? Yes, S2 minus SS1 that equal to lambda by 4 is the given condition, or it is a given path difference in the first case from this to this only. Okay, now we have to find out S2p. We have to find out the path difference of this second case, that is S2p minus S1. Okay, generally we write it at point P for constructive and destructive interference both. So I suppose that initially path difference be this given path difference will be taken as the initial path difference, that is equal to lambda by 4. Now I say that given path difference is of only this path. Now if I say the total path difference, then it will be of this both, this first case plus second case also. So I will add both, means whatever the given initial path difference will be there, that will be added to the final path difference that we have to find out here. Yes or no? Yes. So I have written here total path difference up to point P will be delta x. Generally we take the delta s. Yes, delta x is the path difference, so it will be the sum of both. Sum of both means what? Yes, S2 minus SS1 means of this side, and then another one is a S2p minus S1p, S2p minus S1p of this area. So I have written it down. Now I know that yes, S2p minus SS1 is already given, that is lambda by 4. lambda by 4. Now what is remaining here? That is S2p minus S1p. Yes, fine. So what is my target? My target to find out the, you can see in the to find portion, S2p minus S1p is the target. So I will just rearrange it and I will write it as equation number 1. Okay, you can see that is S2p minus S1p equal to delta x minus lambda by 4. What I have done, I have just transferred the lambda by 4 on the left hand side. Okay, now what is my target? What is delta x? I should know na? Yes or no? What is delta x? It is a path difference. Now it is different for different phenomenon. That is, for constructive it is different, for destructive it is different. So if I am taking this point P as a point for formation of the constructive interference or the destructive interference, then for constructive interference I know that the path difference is given by n lambda. Yes or no? N lambda. Now what is the delta x? Delta x is all n lambda. Fine. Now from the equation number 1, S2p minus S1p can be written as, in place of delta x I will put the value of n lambda. You can see here I have replaced the value or substituted the value of the delta x as n lambda from equation 1. I have given the each and everything here, means along with the reference also, so you can go back to the equation number 1, so you will going to get the idea. So simply I have taken the lambda common from this, so it will be my answer for the half sub question. Fine. Now we know that constructive interference form from the central maxima also, means whatever this position is there, that is the zeroth position. So because of that we can take the integral values of the n from 0 itself. Okay, now for the destructive interference at a point phi. Now path difference for the destructive interference is usually different than the constructive one. Yes, so what is the path difference for the destructive interference? That is 2n minus 1 lambda by 2. So that is a simple formula that is already given in the textbook also, or you may have also noted down in your notes or in your formulas or in your notebook also. So again, now from the equation number 1 I will substitute the value of x. So I have just replaced the value of x here. So I have just replaced the value of x here, and just I have done some rearrangement, means I have just opened the bracket here. So I will just solve it. Now after solving this I will going to get lambda multiplied by n minus 3 by 4. So what is this? It is also S2p minus S1p for destructive interference. In this way, for both constructive and destructive interference, we can find out this particular solution very simply. What we have done, we have just used the two formulae. What is that? One is a total path difference and another one is a path difference only, and we have just written down this relation, and after that we got the solution. Fine. Now we will go for the next question. Another interesting question which also deals with the wave optics, or we can say that is Young's double slit experiment. What is given here? It is related with the intensity. Okay, I have seen that usually we get confused in the intensity questions also. The intensity at the central maxima. The intensity at central maxima in a double slit setup is I0. The intensity at the central maxima is given as I0 at this point. Okay, usually it is O, not a 0, but it is given as a 0, but you have to consider it as O. Now if the distance OP is equal to 1/3, what is this? This is the distance. What is that? We say yn. Yes, yn na? Yes, it is a yn. So basically this is the distance from the central maxima up to the point P. So now it is maximum, means we can say that it is the position of formation of the fringe. That is, now we have not given whether it is a minima or maxima, but we know that fringe width remains same for both dark fringe or bright fringe. So there is no any need to know whether the P is for maxima or minima. Okay, leave it. Now distance OP, so this x is 1/3 of the fringe width, is equal to 1/3 of fringe width. So basically we give the fringe width as a beta, so it will be beta by 3. Now show that intensity of this point at this point P is I2 upon 4. It is I2 upon 4. Basically it should not be the I2 upon 4, it should be the I0 upon 4. Given YOP. What is YOP? That is the distance of point P, or position of the fringe at point P from the central maxima, that is given by x. So I have written it as a given. Now intensity at the central maxima, basically it is given as I0. We have to prove that the intensity at point P is I0 upon 4. For solving this question we will go in the reverse manner. Okay, so what way to calculate intensity? So first I should know the formula of the intensity at any point. So it is ip equal to I0 cos square phi by 2. This is the simple. so i know that I know that it is ip, so it is intensity at point p, so that will be equal to I naught cos square phi by 2 at point p. Yes, now or I naught cos square phi by 2. So what is phi here? Phi is a phase difference. Yes, it is a phase difference, and the relation of the phase difference is, or formula of the phase difference is this on the right hand side, that is given 2 pi upon lambda multiplied by delta x. What is delta x? It is a path difference. It can also be shown by delta p. Now why I have written delta p? Because I know that already 1x is included in the question, okay, as a distance op. So I will not going to include it as a delta x because it will going to make a lot of the confusion. So instead of delta x we have taken here the delta p. Fine. Now my target will be first. So for finding the intensity I should know what I should know. I should know the phi. But how can I get the phi? I will get the phi after knowing the path difference. So first I will require the path difference. So for finding the path difference I will require the fringe width. So first I will take the help of the fringe width. So you can see here what is the formula of the fringe width for maximum or minimum, that is del lambda d upon d. Yes, simply again in the question we have given that this x is beta by 3 or one third of the beta. So if my beta is lambda d by d, my beta is lambda d by d. So because of that my x will become beta by 3. So it is lambda lambda d upon 3d, lambda d upon 3d. Now we will go on the next page. We have already seen that we got the value of beta also, we got the value of x also. Now you can see delta p. Now you can see path difference, that is delta p, can be written as a what is that? We know that that is a beta multiplied by d upon d. Yes, beta multiplied by d upon d. So that is basically we can write in such a way. This is also the formula. Okay, I have not taken it on myself. Okay, it is a formula that is given in the textbook, that path difference is equal to fringe width multiplied by, what is that? Path difference is equal to fringe width multiplied by small d upon capital D. That is, what is small d? Small d is the separation between the slit or width of a slit, and capital D is the separation or distance between the slits and screen. Okay, now we have given this. What is the value of beta? Lambda d upon d. So I have just put the value of beta as a lambda d upon d. Yes, and then again now you will going to ask me, sir, how you have taken the beta small d upon 3d. So you can see this formula. What is that? Delta p is equal to x d upon d. Delta p is equal to x d upon d. What is the x here? It is a distance. Yes, it is a distance from the central maxima. Yes or no? So basically it is a position of any. So what is that x? It is a position of any fringe from the central maxima. So in place of x I have put the value that is beta by 3, and then because of that I got this relation. Okay, now we will go further. You can see everything is cancelled here, means capital D is divided by capital D, small d is divided by small d. So because of that what is remaining here? Delta p, that is a path difference equal to lambda by 3. Now, what was my requirement? My requirement was finding out the phi. So, what is the value of phi here? Phase difference, that is phi equal to 2 pi upon lambda multiplied by path difference. What is the value of path difference that I got in the earlier section? That is lambda by 3. So, I have just put the value of lambda by 3 here. So, I get the phase angle, or we can, sorry, I get the phase difference, that is phi equal to 2 pi by 3, that is also equal to 120 degree. Okay, now then intensity at point P, then intensity at point P. So now I got the phi also, means phase difference also, then I can calculate the intensity. Now you can see that what is the formula of intensity? That is I naught cos square phi by 2. So I have put the value of phi here. So what is remaining here? It will be pi by 3 only. So what is the value of cos pi by 3? That is 1 by 2, because cos 60 is 1 by 2. So I have just put the value of 1 by 2 in place of the cos square phi by 2. So it is 1 by 2 whole square, because it is already square in the formula. So it will become Ip equal to I naught upon 4. So in this way we can say that the intensity at point P will be I naught upon 4, and that is the required question that we have to prove here, or that is the required expression that we have to obtain here. So in this way we can solve this question. I hope that you got this solution of the two questions. Basically these questions are very important and you people have studied a lot, so because of that you have also gone through some question like these questions and all. So you should know how to approach those questions and get the maximum marks by solving these questions correctly. This video will going to help you, and if you find the explanation well, or if you like this video, or if you want to share this video with your friends, and if you want to share this video with your friends or your classmates, so you must share this and subscribe this channel and stay updated with me. Thank you so much. All the best.